So section R.5 covers factoring polynomials. Now I'm going to go over this pretty thoroughly because I want to make sure we're all on the same page, because this is a really important concept that we really need to have in our back pocket and ready to use as we move on through this course. So let's talk about factoring polynomials. So the process of finding polynomials whose product equals a given polynomial is called factoring, okay? We do this because we'll eventually need to solve equations. So if I have the polynomial 4x plus 12, I could pull out a factor of 4 and rewrite that as 4 times x plus 3. So I was pulling out the greatest common factor. 4 and x plus 4 are the factors of 4x plus 12, and this is the factored form. Important note that a polynomial who can't be factored is called a prime polynomial, right? That makes sense. Prime numbers can't be broken down any smaller. And a polynomial is factored completely when it's written as a product of prime polynomials. So it can't be simplified any further. The first way to factor is by factoring by grouping. So what we're going to do is by factoring out the greatest common factor. So we're going to go ahead and pull out the GCF, right? So the greatest common factor is going to be the greatest common factor of the two terms or three terms or more in our polynomial. So let's take a look at 9z minus 18. 9z minus 18, the greatest common factor between 9z and 18 is going to be 9. So we can pull out a factor of 9. So this would be equivalent to 9z minus 2. And you see that if I redistributed this 9, I'd get back to my original equation. In this second example, I've got 9x cubed plus 12x. So I look for the greatest common factors between 9 and 12, and the greatest common factor between x cubed and 8x squared. The greatest common factor between 9 and 12 is going to be a 3, so we can pull out a factor of 3. And the greatest common factor of x cubed and x squared is going to be an x. 3x squared times 3x gives me 9x cubed plus 4 times 3x squared would give me 12x squared. So there we have our fully factored form. Now I've got a trinomial, right? It's got three pieces, 1, 2, 3 terms. So I'm going to pull out the greatest common factor. So the greatest common factor of 24, 15, and 3, that's going to be a 3. And the greatest common factor of k9, k7, and k to the 4th is going to be k to the 4th. 3k to the 4th times 8k to the 5th would give me 24k to the 9th. 3k to the 4th minus 5k cubed would give me negative 15k to the 7th, plus 1 times 3k to the 4th would give me 3k to the 4th. Here I have a fully, it appears to be already factored somewhat. So I see that the greatest common factor both these have in common is an x minus 5. So I'm kind of undistributing, right? I've got x minus 5 times x plus 6 plus 2x plus 5. And then I can go ahead and simplify what's right in here. So I've got x minus 5 times 3x plus 11. So that's how we would factor out the greatest common factor. It's important to note that if I have a negative leading coefficient, I need to pull out the negative as well. So I'm going to pull out a negative, and then the greatest common factor of 18, 6, and 15 would be 3. The greatest common factor of a to the 4th, a squared, and a cubed would be a squared. And then I've got b cubed, b squared, and b, so just a b. So negative 3a squared b times what would give me negative 18 a to the 4th b cubed. That's going to be 6 a squared b squared. And then what would I need to multiply negative 3a squared b by to get 6a squared b squared. Well, that's going to be a negative, let's make that smaller, negative 2a squared I already have, so negative 2b. Then over here, what do I multiply negative 3a squared b by to get to negative 15a cubed b? Well, that's going to be a positive 5a. So I have fully factored this polynomial.